the demand is different in terms of health status, then that health status can be determined by several choices. We learned I want to go to a hospital, go to a clinic, go to a traditional practitioner. I want to do it by myself in my home, asking for my from my mom, dad, or somebody else. So these are choices. What kind of treatment I will take? Where will I? We have already talked about where, or which kind of department I am visiting, for how long I am visiting, or how many times I need to visit. So all this comes into the picture. So these choices, when modeled, then often our health, like our econometric models, deal with discrete choices. Yes, when we talk about the choices, but how much to consume when we ask this question? How much to consume? It's basically a continuous variable. Where to consume, when to consume, why to consume can be discrete, but how much to consume, that becomes a continuous variable. And these choices very much are defined in terms of the, say, the access to the healthcare. If there is access, they will have, the choice is different. If they don't have access, the choices are different. So which are the variables you are really taking into account? You need to, in terms of a developing country, you need to always keep in mind that, okay, fine, here they have access, or here they are, they exist, this particular variables exists, or then we can really figure that out. And if we are looking at these choices, then, or access, they are basically and useful indicator in terms of demand side. And then the demand side interventions are basically say how much user fee they are paying and whether they like to visit those facilities or not. That is the demand side. What is the willingness to pay, or how much they are paying. But in terms of the supply side, what is in terms, when we look in terms of the providers, the choices of the providers, the consultations the providers are giving, what kind of providers they are visiting, or how many times they are going back to the provider. These all are supply side, because how many times they need to go to the provider, even if this is determined by the patients, but it is not supposed to be determined by the patients. It is referred or recommended by the doctors, by the providers. Therefore, this is basically the supply side indicators. But while we are modeling them, they really, they really should not overcome each other. At the same time, we can collect these data from household surveys. The data collection, as we don't have many secondary data, the data availability of data has been problem in countries like India. Even though we have surveys like National Family Health Survey, which started with 1992-93. and continued, 98, 99, 2005-6, and next one is 2015-16, but yet to come out, most likely this year end. So these are the 4 NFHS surveys. Otherwise, we have NSSO, National Sample Statistics Organization. We have RCHDLHS, Reproductive Child Health District Level Health Survey, which is till 4th round we have availability. But then this is, suppose, I don't know, like that may not be continuing, because National Family Health Survey is now giving us the district level data. So this household level data gives us idea about both, even IHDS data, Indian Human Development Survey. ISDS data. It's done by NCIR and University of Maryland, probably, yeah. And then this health surveys gives us a clear idea that about some proxy about the health seeking behavior. How? Let's take an example. They go to these individuals and ask that how many times, did you go for ANC, antenatal checkup? Before birth the women are supposed to go for a checkup. Postnatal checkup, after delivery the women are supposed to go for a checkup. So did you go for that? If not, how many times? It's supposed to be minimum 3 times. Whether they went for, did you take your child for immunization? What kinds of, how many immunizations do you have for each particular, measles, pulse polio, and all these things. And we have an idea through these questions that what is their health seeking behavior, that is a demand for health care. So as we don't have data, and then you can design your own questionnaire, own survey to collect data from the general community. Having said that, so when we have a straightforward price or expenditure and the and its impact on the healthcare demand, or we are, if we are regressing between them, we have said that we are doing an ordinary least square method. But at the same time, if we have or we can do a natural logarithm, and then do an OLS, but at the of expenditure. And if we are having a discrete choice model, when we have, say, what is the decision that when I am sick, I will go to a doctor or I will not go to a doctor, I will take home remedies. What is the decision? If it is like something like that, then that is known as discrete choice models. So I have very discrete choices. Yes, and there are two very prominent, one is logit and one is probit. There is also another one tobit, but logit and probit. So basically in demography or in health economics, we mostly do and logit and probit analysis. And if they say in case of choices, like say it is a dichotomous choice, right, whether I go two variables, so binary logistic regression, what we do, binary logit. If there is a dichotomous model, so that means whether I go for a health checkup or I don't go, two choices or two categories of my dependent variable. If there is more than two, then we have multinomial logit. If we have more than two categories of my dependent variable, we have multinomial logit. And we also need to take, when we are setting a regression equation, we must take the background variables or the confounding factors, which has a control over this, the relationship between my dependent variable, which is related to health, of course, and my independent variable. So having said that, or my decision making, that whether I go for a clinic or not, and those basic background variables can be my socioeconomic variables, the education, the income, my gender, marital status, caste, all these things, yeah, my occupation and everything. So what this that logit and probit does, they basically estimate the relative indices, relative utility of choosing a particular decision. So both this logit and probit, they estimate a relative utility of choosing a hospital or not. That, if that is one category of my dependent variable, yeah, over the self remedies, yeah. So I can explain that this is the probability of going to a hospital if it is with the reference of not going to a hospital, I mean these self remedies. So and this can be explained for each of the explanatory variables separately, naturally, right? And this relative utility of choosing, it's actually an index which is estimated from -infinity to +infinity. So this index value, this indices value for each and every explanatory variable or independent variable, this range between these, this range between this minus infinity to plus infinity, which can be converted to a frame of 0 to 1 considering a cumulative probability function. Yeah, cumulative probability function. So this minus infinity to plus infinity, I can convert it into 0 and 1, and then estimate the probability of visiting a clinic over not visiting a clinic. And then this logit model, if I want to explain it, then if the regression equals y equals a plus bx, y being the dependent variable, x being the independent variable, b being the slope, a being the intercept, if y equals a plus bx, then logit model basically represent it like log of probability of x divided by 1 minus probability of x. Yes, something like that. And we can estimate the odds for each of these x or x plus 1, which is like probability of x, and 1 minus probability of x because is actually the probability of x plus 1. So anyways, or not, yeah. So if we are going to these odds, then it can be an exponential of this linear regression equation. So I can state it like y exponential e to the power a plus bx. So this is my linear regression equation, and exponential to this is my the odds ratio and odds, and when I do my odds ratio, then it's pretty much at odds of one category x plus 1 if it is one category is 0 and another category is 0 plus 1, dichotomous. So odds for that category 1 if that is visit to a clinic, divided by odds of x if that is not visiting a clinic. It's something like that, or we can also estimate in terms of a contingency matrix. If we have a contingency matrix, I'm just giving you a broad overview. You can probably look, this contingency matrix are well studied in epidemiology, whereas this odds ratio in this formula is well studied in discrete choice models in econometrics. Yeah, so contingency matrix is basically if we have A, B, C, D, smoking, not smoking, having cancer, not having cancer, something like that. These kinds of 2 by 2 matrix are known as contingency matrix. Then we can estimate our odds ratio as something like A by B divided by C by D, which is AD by BC. This is my odds ratio. Yeah, so again, this is exposed to a disease, smoking, and this is exposed to not the disease and the condition, and this is disease yes, disease no. That's smoking, not smoking, cancer, not cancer. And you can, so for those who are smoking, happening cancer and not happening cancer, that is the ratio, that's the odds of happening a cancer among those who are smoking, and this is the odds for happening and not happening happening a cancer for those who are not smoking, that is C by D. So this is the odds for those who don't smoke but among them happening a cancer, and then we can estimate an odds ratio as the ratio between these two odds, and then we finally get this AD multiply A into D divided by B into C. Thank you.